Hello, I'm Asim Parikh, and it's my pleasure to welcome Pele Antonio Pellegrino, who goes as Pele, the founder and CEO of Mutable, to our spotlight on 5G connected edge cloud for the Industry 4.0 transformation. Pele is a serial entrepreneur, starting as a whiz kid at 15, started his first company in kind of a streaming company for esports. And that became kind of the number one streamer in that time frame. And then he has done several other startups since then. But uh, you know, why he's here today is that in 2017, he recognized the central role edge cloud would play in the 5G transformation and started Mutable. And I'll let Pele take this from here and introduce himself a little more, as well as Mutable, and talk about the interaction of 5G edge cloud and the whole the market dynamics around that, around edge and around low latency transport. Pele, please take it from here.
Hey, how's it going? So yeah, no, how I got stuck with Pele was quite interesting. When I was in middle school, in one row, it was Anthony Magro, Anthony Passeret, Anthony Pellegrino, Anthony Poto, literally in one row. So we ended up going by our last name, and my dad is also the same name. So I decided to doing gaming, as as you mentioned, more or less, uh, took that on as a hold. So yeah, thanks for that. Yeah, so what I'm doing at Mutable, just to get a quick synopsis and then go into the market, is at Mutable we're building a public edge cloud, but in a really different model. We're doing an Airbnb for servers, and how this plays in with everything is um, when you're trying to build this cloud, right? That's trying to federate across everything. Um, what you can't do is own it all, right? Especially as a small company. So our biggest thing is taking all of these nascent assets that are already in existence. Most of these cable telcos, hosting companies, even enterprises, all have servers. We're on a Zoom, and Zoom itself has servers in New York, over 200 of them, and overall utilization is close to 1% on average over a given year, right? So if we can take all these assets, tie them all together, and make one ubiquitous cloud, and rev share with whoever owns it, we're creating a whole new way for all this to pair together. So that's us, right? That puts us a little bit in context of where we're going with this. Um, as I mentioned, right, working with cable telcos, enterprises, and hosting companies, what you realize is that there's a very interesting world of digital transformation happening right now, right? Obviously, you have the cloud guys, the hyperscalers, and they're putting a lot of effort into trying to get everyone into their cloud. But there's also a lot of vendors that are providing solutions to operators and whatnot and enterprises that typically were giving a black box, right? They were taking these network functions, routers, all these things, and they'd put them on proprietary things, make it very analog, and then trying to make performance that way. The difference now is as you move things towards the cloud, you realize you can do this on COTS or commodity hardware, more or less. And this hardware, more what you're doing is just applying software to change its functionality, right? We do this with phones all the time, right? We have, everyone has a phone in their pocket. We still call it a phone, even though it's way more than that nowadays, right? And with that in mind, you have all these different possibilities just by changing out the software that's running on it or different applications. Now, how this plays out inside of the edge world is with all this hardware now going to generic HP, Dell servers or whatnot, and then just creating functions on top of them in order to do whatever role you want, it means it's not a box that does one thing anymore, right? Which sounds like a no-brainer. But if you're in the enterprise world or if you're in the operator world, it's not a no-brainer. It's scary, right? Because typically you buy something to do something and you call it a day and you don't touch it, right? And now what we're basically saying is all this hardware that you're buying right now that you're maybe running OpenStack or VMware or whatever type of platform, You now have operators with like over 20 clouds in them internally, private ones that they're trying to, for each project, for each domain. And all that can be created into more of a universal cloud. And in that process, you're not just opening opportunities for third parties to come in to generate revenue, to open up the doors for, network acceleration, for applications for gaming or for IoT. You're also opening the door for even internal teams to utilize hardware differently and move applications where they should be placed instead of just buying individual hardware for that one thing. So I say this and it sounds kind of generic, right? But put this in context. You have a lot of network functions that are happening nowadays that, you have SD-WAN, you have, DDoS protection, you have a lot of these, different warps or firewalling on application level and so on and so forth. Where are those placed? And where those placed matters is that's where all the data is going. In order for them to go outside the network or for them to be moved around, it goes through these things. And now they're not appliances, where they're placed matters, right? So some cases that was at the top of the operator's network and you have to transverse the whole entire thing. Then they're like, hey, look, let's move it on-prem and put it on the enterprise's locations. But now you have this weird middle ground where you actually can move these things on demand based on what's happening, how much traffic is going on. And that changed performance and SLA metrics that weren't available before, right? So instead of having, this application forced to be on-prem, which means you have to have IT staff. Now, I'm putting this in context to an operator, but think of this in a retail setting, right? Retails are now doing, if you go to a Walmart today, 80% of the checkout is now self-checkout. They're trying to get people to reduce workforce, reduce you touching people, and people are more likely to, because of interacting with the internet, are more happy to do things on their own without talking to people, without being on a phone. So with that in mind, what that means is you now have an IT staff that now has to come in and support all of this hardware, right? They have to manage the software that goes on this hardware. Basically, you're creating a whole IT empire that now has to cross every single one of these stores and make sure everything's working properly in order for this to run. Now, what if one of those servers go down? And a lot of these things are single purpose. It means that you have now machines that are completely down. And so that 80% that you were relying on self-checkout is now completely screwed, and you have to now, get people back on these long ass lines to be able to do this kind of work through a normal checkout process. So these type of things, if you were doing this on the operator edge, who's already doing the SD-WAN for these retailers, it's as if you're on premise, but you're really just right next to it. And the benefit of that is you don't have to have IT infrastructure anymore. You're just using the network like you normally would. You don't have to go all the way to the cloud. So you're still having the security blanket of your SD-WAN, but you now can run these applications in that safety blanket that is right next to where your retail stores are. And that kind of thing is a huge digital transformation, not on the hardware, but actually on the IT group and how that works. And so the changing of those type of groups is going to change behavior on what type of vendors you can support, right? If you're doing that type of solution, you're going to go with an IBM because you're going to be like, well, I need someone that can support being at my location, within 30 minutes or an hour or whatever it may be. But if this is running on elastic compute, just like it would be on the cloud, but nearby, you can then extend that to the new startup vendor who's just trying to figure out how to, they might not be the best salesperson, but they are 100% better at technology than, a big corporation who's just focusing on trying to reshuffle some of the assets they already have. And so the more that we can allow these startups or companies that are really heavy tech focused and enable them to play in this enterprise world with less risk on behalf of the enterprise, because if they're not requiring specialty hardware and you can run multiple versions of different vendors at the same time to test them out and do all these types of things remotely, you can create a new world where we can actually push this digital transformation a lot faster than what we've been doing for the last 15 years. The last 15 years moving to the cloud has been a rough move, right? You have big shifts of, every time a new CIO or CTO comes in and changes their behavior of, hey, look, we need to do this all on the cloud, so let's abandon everything we have, to, oh my God, we're giving too much money to these guys. This is not what I expect. Let's move it all the way back, right? And this yin and yang going back and forth is creating a lot of chaos. So once again, how does the operators play into all of this? The operators play into all of this because one, they provide network solutions, including SD-WAN, which is the firewall blanket, but also because of their locations. Most of them have, if you're in the cable land, it's the head end or hub sites. If you're in the telco world, it is your central offices are within 25 miles of every one of these customers' locations because they have fiber directs, right? It's either fiber or coax, whatever it may be. They all go to these buildings that used to do a lot more than they're doing today. Right now, it's a rack of fiber connectivity that's passing through, and that's about it. Where before, some of these things were doing, television-based, distribution with coax and all this hefty, high power, high heat kind of situation. Even phone systems, all that's gone, right? It is now just network, IP stack, right? And so the more that we can reutilize these locations that are ridiculously awesome real estate assets and convert them into, essentially, I don't want to say co-locations, because co-locations requires on-hand people. It requires access to things that typically you don't want people to have access to. Meaning you don't want foreign people inside of your head end or CO. That is very dangerous as a security blanket and everything else. But you can provide solutions out of their at least raw hardware. And that's where a company like us would be able to come in to take that raw hardware and be able to convert it into a cloud, a federated cloud that everyone else can participate to. We'll help do the sales. You're not going out and trying to, bring in a Spotify or bring in some of these IoT-based companies. They're doing, network acceleration and stuff like that. We'll help do that, and then essentially we're letting you just take that extra effort of being able to sell additional offerings or be able to monetize the network traffic and reduce the amount of backhaul that you're doing on all these locations. We all are part of what's happening in the wireless world today, not just with CBRS, but what's happening with 5G. And in that process, we're creating a lot of, I would say, high-speed access networks that weren't available before, right? So instead of, our bandwidth cap or throughput being closer to 5, 10, 20 megabytes per second, we're now going to hundreds to gigabit per second. And that could be over, a millimeter wave where you can do this with one channel, or with mid bands or low bands where you're going across multiple channels. And in doing so, it's like the gym membership model, right? Where you typically would have this much equipment and this much space, but you'd oversell it because not everyone would be using it all the time. But if you're talking about IoT, completely different story. Because with IoT, you're trickling data all the time from every device. And so now, where you're only giving 10 gigabit backhaul or 40 gigabit backhaul, it actually becomes a huge bottleneck. Because each one of these, subscribers, typically you would think only would do, a small amount at different times of the day, or bursts at different times of the day. If you have a consistent amount with every single subscriber, where some of these radios can, because of MIMO and because of beamforming and all that fun stuff, you can now do 50,000 to 1 million devices connected to these radio heads. And when you do that, if you're in a stadium, right, and you now have all these cameras going around for what's going on, instead of putting little smarts in the camera, you're now putting the smarts inside of the compute on the network, right? And if you were to do that and have these $50 cameras that you put everywhere, instead of these $5,000 cameras that you'd put everywhere, you now have to take all this transit of upload of these feeds and do something with it, right? And the access network can handle it, right? Before that was more of an issue with licensing and everything else. Now it can, but the backhaul can, right? And so that's where we can actually get some of this compute more closer to on the edge or next to that access network. That's where we can change the dynamics. If you're doing it privately with a CBRS and a Nokia or Ericsson setup, or you're doing it with an operator who's trying to sell additional services to change how their business works. Instead of it's just being about selling SIM cards, it's now being about value-added services. That's where this type of thing really plays in. I can go through a bajillion examples, but I'd love to
No, I think this is very thought-provoking, and I see where your differentiation is, how you think about the business model. I have a bunch of questions, so let's kind of go. I've started taking some notes when you started to speak. So you talked about Airbnb for servers. That's an interesting concept. But in the world of enterprises and especially industrial kind of users and consumers, when you talk about Airbnb or any kind of usage which is kind of shared, the reason people don't use more than 20-30% of the compute is because they want to plan for the peak or the plan for the worst case scenario, right? Absolutely. So how would the availability of an SLA metrics, which you also mentioned, kind of be impacted when you don't own, first of all, the resources, nor can you control the availability of resources when you want them, because some other tenant of that service would have suddenly hogged up 70-80% of the available compute at that given 1 hour time frame, and now you are left with, now you need to go to the next data center, which is maybe not 40 kilometers away or 40 miles away, it's 1,000 miles away. What happens then? So those are the scenarios. How do you handle those?
Yeah, I know it's an interesting challenge, but if you think about it, the cloud technologies have gone a long way, a very, very long way. Before we had dedicated things with bare metal, then we graduated to VMs and virtual machines, where it's like you're getting a slice, and that's time sharing to some degree. And obviously we moved to containers, but the next step of containers has been serverless. And the concept of serverless is not as running functions or anything like that. It's that you don't care about the hardware that it's running on, right? And that means that hardware can be replaced out as long as the specs that you need to run that application are the same. And so what's interesting about this is what we're doing over here is the Airbnb for server model is, if you're the owner, you get priority. Anything that you want to run, you run. Anything else gets kicked off if it has to be to another server nearby, right? Now, if you only are working with one operator, if you're only working with one data center location, that's a problem, right? Because where are you going to go next? Yes, it's going to be the cloud as the next point. But that's where layering on all these other tiers comes into play, right? If you look at COs and head ends, they're all fiber ringed, right? What is the latency between each one of them? 1-2 milliseconds max, if that. Most of the enterprise locations, that's not really a real big problem. The one that's a problem for is actually the operators, because they buy equipment for certain reasons and those things have consequences. So totally get that, right? And even enterprises, if they're putting in their own hardware, they might need it for machine learning, they might need it for image recognition, they might need it for whatever, and so they have specific hardware for it. Totally get it. While everyone else can be moved around without any consequence, because what we're doing is just routing the application and spinning things up where it needs to go. So that changes the dynamic of redundancy, which, as you said, is one of the things that people put out there when they buy hardware, especially in those locations. It's like, I've already spent X amount on this location. I've already spent this much on, redundancy on generation. I've already spent this much. What's the difference of putting one server or two servers, right? Or multiply that out. But if you think about it, that's a lot of compute laying nascent 99% of the time, right? So for 99% of the time, if you think about how was Amazon created AWS, or Google create Microsoft creating Azure, it was off of these guys are software guys who has a bunch of equipment but aren't using it all the time because they have the worst case scenario that they're predicting and planning for in peak. And I think it's the people who do it the worst in management is the operators, because they have the most critical problem, because they can go in front of Congress if it doesn't work properly, right? So totally get it. But in this model, essentially allows us to use those resources without consequence to them, while everyone else can now take the benefit, and we can just tier all of this compute together, going from the access network to the regional data centers of that operator to hosting companies to the cloud. Worst case scenario, where today that's probably the best case scenario that most developers deploy to.
No, true. And I think when I talk to these enterprises and the kind of the industry 4.0 people who want to achieve those goals of transformation, digital transformation, they kind of partition their world into two. You talked about IT, but they also talk about something called OT, operational technology, right? And the IT pieces, their billing systems and the customer CRM systems and the ERP systems and all of those things, kind of they classify on those things, and they are very, very comfortable now after the last 10 years of using public clouds and AWS or Azure or what have you, right? But when it still comes to the operational technology, where like you said, they are single purpose machines, compute machines, which are responsible for running a lathe machine or a CNC machine or a drilling machine or a painting robot. Those things, they think of them very differently, and there are multiple reasons. One is obviously the latency and control. The second is data sovereignty. They don't want the data of those processes and all of that to go outside their location. So that's where kind of the edge moves from the customer, from the provider edge to the customer edge, right? And things what they want to leverage are, yes, they don't want to now have a single purpose compute server dedicated for each. They want to run these on clusters and Kubernetes and Docker-based systems, where they could have the redundancy of hardware and be able to move the job across multiple servers if one or there is no single point of failure in that scenario. But there is this heavier ask of running kind of an operational technology job. So they have to be either experts, or they have to be managed service providers who provide those services like maybe a mutable type, but on their prem, right? So I'm sure mutables technology can obviously work with any compute. But is that something have you looked into that, the operational technology enablement of and how do you digitally transform those processes, which are like you talked about Walmart smart retail, right? They are video cameras now. They are not trickling IoT, 20 bytes of data every minute. They are doing 2 megahertz of 2 megabytes of data per second, right? And how do you take hundreds of those cameras sitting around the Walmart kind of store, compute them, do some AI, ML, some heuristics and some learning on it to direct whatever their automation processes are. So what do you think about that?
I think you covered a few things. So one of them is a behavior problem, right?
Yeah.
Just like we had the behavioral problem of people using the cloud in the first place, you really think what a cloud is, it's another person's computer. Right? That's all it is, right? Running compute on another person's computer. But then there became private cloud, and private cloud was running stuff on other people's computer, but you still own it, right? It sounds weird, but that's kind of right what the process is there, right? In terms of who manages it and whatever else. So operational technologies, mission critical things have always been or perceived mission critical just because of the nature of what they are, not necessarily that they are mission critical, has always been in the separate class of, oh my God, we can't let anything run on it in the same kind of world because life's going to cease as we know it. While everything else that you just talked about before, ERP and all that kind of stuff has moved to the cloud because it's like, yo, I can just use a vendor and pay for it on a subscription basis and be done with it, right? I don't need to host it myself or use SAP and direct and blah, blah, blah. I think the tree hugger movement is what I call it, where a developer or engine or ops person basically hugs these servers and are like, they're mine, don't touch, right? Is starting to become different because I think the sysadmins are aging out. The people who typically would manage these servers, who grew up being like, I need to manage everything because I don't really have, I need that control because I need to make everything run, and not having all these open source things or not having all these tools available are actually becoming scarce, right? Now everyone's growing up in this cloud world, and so they only worry about APIs nowadays and not necessarily how to manage these things on an individual basis. So for our point of view, the cloudification of these hardware pieces, where if vendors want to deliver a container, it's becoming really hard, where vendors are asking us, can we push you inside of this operator so that way we can run on you versus running on this OpenStack platform that they're doing, or vanilla Kubernetes that's basically segmented for each CO or whatever that they're doing. So the world is changing in that kind of regard, and I think this provides additional value on why they would do it. And this is kind of like a CFO sell, right? Where it's like, you pay for all these assets, they're literally sitting there, servers rot, right? Every 4 years, you kind of need a refresh. Why aren't you maximizing both the real estate as well as this compute on making money on it, and not just give it every dollar to a hyperscaler, right? Second with that is you're going after, you're explaining, can Mutable run on-prem? Doesn't make sense for us to run on-prem because of the scenarios where you have so much cameras that why would you have a data uplink go all the way up to the cloud, to the operator, CO, or whatever, to do these type of things. So there are reasons why we would go to a retail edge or an on-prem solution, and we originally are trying to stay away. But the reason why is we would do it is because we're really trying to create a marketplace. If you really think about it, right? This is supply and demand. You have compute, you have applications, but you also can think of it as we're a marketplace for startups or heavy technology companies to enter the enterprise world. So in our world, if we can take this compute and generalize it, where if someone pulls it out and we put another one in or whatever, and it doesn't break anything because we have redundancy somewhere nearby or whatever else, then I think that means that we can take some of these technologies that should be running on-prem and be able to accomplish the same exact goal and still be part of the marketplace, because we're basically enabling the marketplace of vendors to participate instead of it just being, a Spotify. There's no reason why a Spotify should be running inside of a retail store, right? Totally get it. But it does mean that the vendors that are providing solutions only want to build once, right? They don't want to rebuild, reconfigure, and have their developers and change their product every time they go inside of a new situation. And that's what it is today, right? So in order for us to do mass IoT even, you have to, do individual embedded programming more or less, so it connects to the right cloud and do all these type of things versus it being more generic. So the more that we can make ubiquitous compute happen and be on all these different platforms, meaning cloud all the way down to on-prem and everywhere in between, including the access networks, the more a developer only has to, or a company needs to build things once and deploy it everywhere, we can use data to determine where it gets deployed and optimize against that.
Okay. No, so then maybe you can clarify this. So obviously, people like IoT, Azure IoT, Greengrass from Azure, and Outpost from AWS and others are targeting similar kind of build once, use our whole ecosystem, whether it's in the cloud, whether it's the public cloud, whether it's the edge, whether it's on-prem. So how does, it looks like Mutable is creating another platform which is similar in scope and at least in the use case, if not the technology. How does Mutable differentiate, and how does it compete with that kind of the when you can run the same workload either on the edge or in the public cloud? And uh, so the marketplace concept, I'm maybe not getting it fully. How does
Sure,
Mutable
sure.
attract people to that marketplace?
So you also have to think of perspectives, right? What is at the end of the day Amazon's, Google, and Azure's motive? They built these humongous data centers, humongous, right? And now they need to keep them full. So and expand more. So everything with Greengrass, everything with Outpost, everything with most of the platforms they're doing is a consumer would rent this out. They would pay almost the same, mostly more than they would running on the cloud, and then they would essentially just pushing all the data to the cloud at the end of the day anyway, right? What we're trying to do is, because we don't own any data centers, we don't own any hardware, our job is do data gravity. How do we run applications where they should run, period, and treat this more as a, create the network as one big computer, right? Versus how it's being done today, where everyone has disparate networks. And even if you have AWS going into operators, how are they thinking about it? They're thinking about, I need to be in all these metro areas that already you can get co-location or hosting today, and I'm going to just sit next to these guys and do my own thing, right? What we're talking about is a little bit fundamentally different, especially when we're working with operators, is we're actually talking about working, like, for example, I moved over to Broomfield, and I'm right next to Cable Labs, and I've been working with them for a couple of years. And Cable Labs creates more of the IP for all of the cable companies. What I mean by IP is all the intellectual property of data over coax and all that kind of stuff is created more or less for them, and all the other operators consume it because they all pay into it. With that kind of technology and understanding how it works, we actually can make our platform or orchestration be aware of what's going on. And because we're working with some of the vendors that are doing analytics of proactive network maintenance and all that kind of stuff, we're feeding that into our orchestration. So that way we can actually move workloads around. So for example, if you have the new season of like the prequel to Game of Thrones coming out, that's going to destroy all these operators' networks, right? It's, and so if we can be like, what, how about we move that to the edge of the network when that's happening, even the login process for HBO Go to the edge of the network. So that way we're reducing all that time. Sometimes it's not about delivering content. It's about the actions that you take to get to that content. And the more
user experience it can enable, right.
Optimize the network. So that way we're moving things to, if you think about a tree, right? And this is kind of how networks work. You have this one big trunk, then you have these branches, and then you finally have these leaves. And the leaves are the access networks or whatever it is. And all of them can be combined and go into the trunk and then goes into the soil. Well, what if we just make things run on the leaves and everything else can be skinny, and you're not spending all this money all the time to make that trunk bigger and bigger and bigger, right? So we think about the network as part of the system, and these type of solutions are just individual things connecting to the cloud, and everything in between is kind of not important. And the second
so you talk about your orchestration system, and it looks like that is kind of your key differentiator. So is this something natively grown, or you leveraging something? Are you, first of all, cloud native? Are you Dockers? Are you VM, or you don't care?
Yeah, so what we provide is for developers to use is both containers and VMs, but we do it over a Kubernetes API. We had a proprietary thing, and then we were building stuff before Kubernetes was really main thing. And what we realized over the past few months, like in the summer, that Kubernetes API itself has become the standard for everyone to use. What actually happens in the background doesn't really matter. It's the API. Like, containers aren't really a thing. Containers without service discovery, without all the other things around it, without the structure of the config, really isn't much. And so we realized the whole ecosystem is surrounding the Kubernetes APIs itself. And so that's what we did. We adopted everything so you can use kubectl like as you would, essentially CLI normally. But we're adding characteristics, and that's the extension part, where you have service definitions where you include, hey, I need CPU, I need memory, I need GPU. We're also adding in latency, right? And so latency is also from the end user making the request, but you also could think of if a service is calling another service and we have it defined by latency, we can spin up these microclusters on demand and then spin them back down when they're not needed. And so you're basically controlled chaos behind the scenes of spinning things up, spinning things down, spinning things up, spinning things down, moving things around. But that controlled chaos is allowing efficiencies, and instead of one box being able to run 10 applications or before one, you now can run thousands because who the hell cares? You're just spinning it up as you need it, right? While still letting you use full big containers, not function as a service, not workers or something like that, like you would with Cloudflare. We're anycasting the whole entire system. So wherever we go, we have BGP sessions, so that way you're always hitting one IP more or less, and you're able to get access to the entire network. And things spin up when you need it, right? So that is a huge difference. Once again, where you're not just buying hardware to run this particular application, kind of a test scenario. We're talking about distribution and thinking about ubiquitous compute, where you're not just in a metropolitan area, but you can be, for example, working with a company like GCI in Alaska, rural, as rural can get, and still be able to have that ubiquitous compute for those oil rigs or whatever it is going out there.
So we talked a lot about compute. I want to focus a little more on the connectivity piece. How does Mutable see its role in enabling better, faster connectivity? Do you do anything on the 5G, 4G, LTE side, or any other Wi-Fi 6 side of connectivity? Have you enabled pieces there?
So enabling is a tricky thing, right? We enable it by we're enabling companies to run it, right?
Okay.
We're not doing it ourselves.
Okay.
We can't do everything. We know that. Yeah. Even a lot of the business analytic tools that are on top of Amazon services, AWS, we're not going to be able to build them all. That's straight out. But we will be able to partner with a whole bunch of companies that are doing this and give that diversity that people can choose from. And that's kind of where the marketplace ties in, both on the use case internally, meaning like they need to use it for proactive network maintenance, they need to use it for drones or whatever it is, people and all that kind of stuff, but also on the dev side where you're providing APIs for developers to use. So we're trying to partner with companies to run on the platform so they can add those services to it, instead of everything just being us, or trying to see what everyone's doing and make it ourselves. No, there's so much volume out there just to get those, compute and tie that into the network than it is to, make the other additional services on top.
Right. So our thesis at ONF is this, what we call the connected edge cloud, right? Mm-hmm. And obviously our bearings are from the connectivity side more than the compute side. So we have disaggregated and softwareized most of the operators' functions in the edge or the access side of the network. But we see that this kind of trifecta of compute, connectivity, and software-defined orchestration and the cloud technologies, right? If we can bring this three together, I think magic happens at a very interesting level, and that's the kind of the platform we are building. So you see those kind of synergies, and that's why we are building a platform which is non-differentiating in these three respects, on top of which you can now bring in your go-to-market or your own secret sauce as a company or as an operator, and say, this is my value add, but there is a lot of underpinnings of how to make Kubernetes or what have you as your kind of your orchestration system for these clusters or these compute nodes. work very well with connectivity and embrace connectivity and do connectivity at a hardware level, at where you are guaranteed connectivity to the clusters at the right time, right? Because if the clusters are running fine or your computer is running fine, but the connectivity drops, you are still in the same mess, right? So both sides of the kind of the three-legged stool are kind of important, right? Otherwise, you're not going to be able to stand that up.
Yeah, yeah. But I also, so it's weird because you don't want them all to come from one company, but you
Mhm.
want them to be integrated, right? And that's the
Right,
trick, right?
right.
Because a company that does everything, is master of
Can
none.
do it.
Time, if they're not working together in synergistic or harmony, they're completely useless. So that's kind of like the story of OpenStack, right? To some degree,
Right.
it's kind of one of those things where you have a whole bunch of people that are smart and doing their own individual thing, but when they pull it together, they didn't make it for each other, and so you just have configs everywhere, right? Where in reality, the hardware network all needs to work together. Um, and the orchestration needs to think about this in how it's built to take into consideration all these aspects, because that's completely right, right? And it's weird, and that's kind of where the operators, typically would just be like, oh, I'm just a backbone, right? To now being more of an active participant, and being able to capture more of the value, because if they're part of the business model. And I think this is really missed out in a lot of these conversations, is the business model requires everyone to also play together. Because if everyone's just selling their own thing, the value isn't there, right? So for example, IoT today, if you get connectivity, how are you paying for it? You're paying for it as if you're getting a SIM for a cell phone. That's not the same thing, right? So you're expecting burst capacity, high throughput, but very short amount of time, in the gym membership, right? As we talked about, versus a whole bunch of smaller devices all doing a smaller amount of data consistently over a long period of time throughout the whole day. Um, like you don't charge per gigabit at that point, right? You charge in throughput at that point, right? There's different models, and to reduce it, because right now, in order to get a plan, you're paying what is it, 40, 50, whatever bucks a month, all the way up. Versus if you're doing an IoT device, the IoT device might only cost like 10 bucks, right? Or 15 bucks or whatever it is. And
No.
you can't pay for having 20 of those just because the connectivity aspect throws that whole aspect off, right? So that's where
I mean,
all,
that is the whole
even
argument
private,
around
right?
not
They,
using network operators or mobile network operators for that connectivity, and using some kind of a private 5G connectivity solution, which
yep.
the cost of per SIM per month has to go down to $1 range, right, for it to make sense.
Yeah, it's more of a business. Now, if they weren't focused on that as the revenue, right,
Right.
and they would just give that connectivity away, but actually make money on the value add of that data, then that'd be a different story, right? Because people pay for value add. They don't pay for just doing something typically, right? That's not how they like to pay for things.
Sure.
So that's kind of where I'm not saying that operators should also make their own or sell their own APIs or services, because that's also dangerous, because you make walled gardens that way, right? And then nothing gets built because they aren't the best at building software. So it's the marketplace approach where more of this can come through, and they get a cut of compute running on it because their own customers we're trying to play in, where whoever is the server owner is getting a 30% cut, whoever makes the cell makes 30%, and us making 40 for making it a turnkey solution. And we might do the cell, but it might be the operator, it might be the startup, whoever it may be, and we're distributing that value across. That's also a big differentiation between us and a hyperscaler who's just gonna throw some boxes in and throw you some peanuts.
Very good. No, this has been a fascinating discussion. Thank you very much, Pele. Any last thoughts before we say goodbye?
So I would just love for everyone to think, right? What life would be like different from you in building technologies or consuming it if you had ubiquitous compute low latency, all that kind of stuff, as if you were to have electricity, right? So today, you can have a battery, you can carry it around, you have a thing you can plug in wherever you go, and that ubiquity allows us to have, no more mechanical things anymore, but everything with electronics. So imagine that doing it with compute, all the different types of things that you can create, because we're going to need to start creating them in the next few years.
Wonderful. Very, very exciting perspective and exciting future in front of us. Thank you so much again.
Absolutely.